Okay, if we take this function and do what we've been doing, find its zeros using the quadratic formula, or factoring is okay, but quadratic formula works, but factoring doesn't. You can factor that, it's x minus 6 times x plus 1, and giving you zeros at 6 and negative 1. Okay, so we know how to get all this. Everybody seems to be doing pretty well with this. So if we have our vertex at x equals 5/2 and y equals negative 12.25, which is just the, so it's like we've got negative 10 here. Okay, and our y-intercept is at negative 6, right? So we're going to have a y-intercept here. Then we pretty much know what our graph looks like. It has to down here and then back up here. That's not overly well drawn, but if this is 5/2, then that means 1 is like here, 2 is here, 3 is here. So maybe we have 4, 5, maybe this is around, actually it came out right at 6. So I just kind of lucked out. I wasn't even thinking about where it should be. But my negative 1 didn't work out real well. That's between negative 1 and negative 2 the way I drew it, okay? So anyhow, we have our zeros. And Eric, I'll just mention on your homework, which I meant to bring and didn't, but everything looked really good, except you weren't doing your zeros. And you know how to do the quadratic formula. So that's no problem, just be sure you do it, so you get the complete picture, so you know where the zeros are, the axis center, and the intercept, okay? But yeah, your work looked really good for this course. Okay. Well, there's our function. Now, this is just a transformation of the y equals x squared graph. Okay? So you take the y equals x squared graph, which would of course go through 0, 0, and if that's 10, 1, 1 would be about here, and 2, 4 would be about here, and negative 1, 1 would be about here, and negative 2, 4. So your graph of didn't come out very well. Y equals x squared would be this green graph. Now, if we take each point of the y equals x squared graph and move it 5/2 of a unit, okay? Then the vertex, well, we have to move it okay, we're going to move it horizontally and we're going to move it vertically. So we move it 5/2 of a unit this way. So that's like 5/2. And then we move it down 12.25. And now the vertex is down here. Okay? Now if we take any point on this green graph and use arrows of the same length to move that point over and, in this case, down, to move it horizontally and vertically, well, we're going to have to move it from this point, we're going to have to move this far. So we're going to be about here. Then we're going to move down this far. I didn't move it nearly far enough here. Okay, that's this far. This one should have been over about here, and then we go down about to here. Nice and slow, and erase that. Okay, so here's our 5/2. Here's our negative 12.25. Put a negative sign in front of that. Okay? Now geometrically, you understand what I'm doing. I'm taking any point of this and I'm using the same two arrows to move that point. And when I do, it ends up on this graph. Okay? So this point will move over about this far and down to 12.25, and it'll give me a point on this graph. Okay? I do that with all the points in the whole graph of y equals x squared, and I get the whole graph of y equals x squared minus 5x minus 6. Okay? So we can see that we have a horizontal shift. The y equals x squared transforms to the y equals x squared minus 5x minus 6. By horizontally shifting every point five halves of a unit in the horizontal direction. And I'm being redundant. I said horizontally shifting in the horizontal direction. Obviously, by horizontally shifted, it's in the horizontal direction. So I can move one of these horizontals. I'll cross that one out, but you could as easily cross this one out, okay? But I want the horizontal to go with the direction, okay? So I'm going to do it this way. And vertically shifting this point okay? Now, shifting 5/2 unit in the horizontal direction. This gives us the function y equals x minus 5/2 quantity squared. In other words, we take x and we replace it by x minus 5/2. Now, Megan, you've done this. You went over it, and we've gone over it in our class in a similar way, so that should be sort of familiar to everybody. And then this gives the function x minus 5/2 quantity squared minus 12.25. Okay, now the points I get from just the horizontal shift are going to be like here and here and here. So we're going to have a parabola through these points, and this function is y equals x minus 5/2 squared. And this function here, the one on this graph, has to be x minus 5/2 squared, but we've lowered everything 12.25 units in the y direction, so it's going to be minus 12.25. And this should be x squared minus 5x minus 6. So now we want to check our result. See if this is really equal to this. Okay? Now there are two ways you can show that this and this are equal. They have to be equal if we've got the right vertex here. Okay? But, you know, I did this in my head. I'm not sure that 12.25 is right. I've double checked it 2 or 3 times and I'm still not sure. I wouldn't bet a lot of money on it, but I'm pretty sure it's right. Okay? But if we do this, and if you do it, just to keep me honest, then I'll really believe that I did it right. So how are we going to show that these two are equal? Well, x minus 5/2 squared is x minus 5/2 times x minus 5/2. So we can write this expression as x minus 5/2 times x minus 5/2 minus 12.25. Okay? And then we can multiply this out using the distributive law. This equals x times x minus 5/2 plus, well, let's say minus 5/2 times x minus 5/2 minus 12.25. Understand that step? X minus 5/2 times anything is x times that thing minus 5/2 times that thing. That's the distributive law. And you look a little dubious, so maybe we need to talk about the distributive law a little bit more, but let's assume you understand that pattern. I'm sure from the work I've seen that it'll come back to you quickly if you don't. Okay? But now go ahead and multiply this out and multiply this out and show me what you get. Okay?